In section 2-1, I want you to be able to solve two-step equations and also multi-step equations. But before we do that, I want to go over a few vocabulary words. The first one is an algebraic expression, and that is a mathematical statement that can contain ordinary numbers, variables like x or y, and operations. And when we're talking about operations, we're talking about like add, subtract, multiply, divide. Now, expressions do not have an equal sign. You can take that A out there and just put equal sign. But if we talk about an equation is a mathematical statement that takes two expressions and sets them equal. So expressions do not have an equal sign. Equation takes two expressions and puts an equal sign in between. Now, a solution set is the value or values of the statement that make the statement true. Let me say that again. The value or values that make the statement true. So when you solve, you're finding something that if you plug it back in, it's going to make the statement true. Okay, a linear equation in one variable can be written in the form of ax equals b, where a and b are constants, and a cannot equal 0. Now, the reason a cannot equal 0 is if we put a 0 in here for a, it would turn this whole side into a 0, so we would lose our x to the first power, which means it wouldn't be linear anymore. Okay, I have a couple of things I want you to add to the left-hand side of your notes, because as I'm going over what you need to check for to see if it's a linear equation, I want you to also put down an example of what it would look like if it's not linear. So when we're doing this, we have the variable cannot be under a radical sign. So square root of x is not good. So we're going to put that over here under not linear. Square root of x represents a nonlinear expression. And then the variable cannot be raised to a power other than 1. So over to the side here, we're going to write an example of something that like that would be x squared. And we know that's quadratic. The third thing is the variable is not an exponent. So we can write 3 to the x. And that would be exponential, which we'll talk about later this year. And the fourth thing is it's not in the denominator. So you can't have 3 over x. So that would mean those things are not linear. Now, I do want to take a look at the examples that I gave you. Linear equations in one variable. So basically, all you need to do to tell if it's linear is look at the variable. And here, all of these that I'm highlighting are raised to the first power. They're not under a radical sign. They are not. The variable is not in an exponent, and the variable is not in the denominator. Now, if we look at these nonlinear ones, we can see right away here, x is underneath the square root sign, so not linear. Also, this one breaks two of the rules. X is in the denominator, and it's raised to a power other than 2. And then this one breaks the rule that the variable is in the exponent. Okay, just be careful when you're doing basic algebra. I see lots of mistakes all the time. We want to solve for x, so we want to do PEMDAS backwards, which means we're going to do subtract and add first before we multiply or divide. So just put a little box around the x, and you need to get everything else away from that. So we're going to subtract 5, do the opposite operation. This is going to be 3x equals 9. And now if I'm multiplying by 3, opposite operation is divide by 3. So x is going to equal 3. And that's your solution. Now over here, a lot of times students want to multiply first, but we need to get the x term by itself. So what we need to do is we need to add 1 first. Then we have x over 5 equals 8. Now the x is by itself. We can multiply by 5 on both sides, and we have x equals 40. Okay, so those are two-step equations. Now we're going to flip over to the other side and work on some multiple-step equations. And there's a couple of different ways you can do this one. You can distribute first. So that's going to give you 4m minus 48 equals negative 36. And then we can add 48 to both sides. So that's going to give us 4m equals 12. And then we can divide both sides by 3. And you have m equals 3. Now the other option that you can do is you can divide both sides by 4. So if I have 4, if there's no adding or subtracting, you can divide both sides by 4. So that's going to give you m minus 12 equals negative 9. And then if I add 12 to both sides, that's going to give me m equals 3. So you always want to get x by itself first. Okay, let's go ahead and do the next one over here. And there's no adding or subtracting. Remember, you need to do that first. And we need to get rid of dividing by 2, so that's going to be multiply both sides by 2. And that's going to give us, when you multiply and divide by the same number, it turns into a 1. So it would be like 2 over 2 equals 1. So that would be x plus 5 equals 19 times 2 is 38. And then we're going to subtract 5 from both sides. So that's going to give us x equals 33. Okay, you have a couple questions to try.